Papalopodocus. All right, second one. Change it into logarithm, so ln changes to e changes to ln, not I, L for logarithm. So ln, oh, it'd be helpful if I saw what I was looking at. Okay, log, so that's got the e covered. So now the x and the 32, what comes first, the x or the 32? 32, because remember the logarithm equals the exponent. All right, you're going to do the other two on your own. Let's skip on down to number 6. Okay, take a few moments. You need to use 2 logarithmic properties, which you have to have memorized for the test. Try number 6.
Yesterday was so
I'll give you a hint. We have to work with these 2 little numbers. Okay, so the numbers in front are really the exponents. So in order to combine this into a single logarithm, we're going to take them. We're not going to make them a single logarithm just yet. We're going to get close to that. So ln 4 cubed minus ln 2 cubed. Okay. Y'all are honor students, so we can do 2 steps at once, can't we? Yeah. So ln, make a parenthesis, make a fraction bar, because we're going to use the quotient rule. Okay. 4 cubed, 64, 2 cubed, 8. But your answer should always be simplified. So my final answer here is ln 8, because 64 divided by 8. Hey, how do I know my answer is correct? Plug it into Desmos. So I'm going to put in to Desmos. Hey, what happened? I know I have. Look at this. I have a Unit 7 logarithm review. Okay, which number is this?
6.
Oh, I don't have a folder for that, so I'll make one. So I'm going to write my original. So it was 3ln. Oopsies. 3ln 4? Oh, 3ln 4 minus 3ln 2. So that answer is 2.07 blah, blah, blah. And then my answer was ln 8. Hey, look, if they're the same, I know I'm correct. That's what I got to do. Right. Let's do 7. Okay. You're going to solve and then round your answer to the nearest 10 thousandths. Give me a few minutes to work on 7. Variable in the exponent. I don't want the variable in the exponent. Take the natural log. Right, so ln e to the power of x plus 6 equals ln 4. Okay. Remember, ln of e is, so when this x plus 6, so last time we moved the exponent up. This time we're moving the exponent down. So x plus 6 times ln of e is just x plus 6. Now, here's where you need to be careful. Like, oh, I just subtract the 6. And that is exactly what you do. But you do not subtract the 6 from the 4. It is not ln of negative 2. Besides, can you take the natural log of a negative number? No. So my answer here, it's going to look a little weird. X equals ln 4 minus 6. I can have a negative number. I just can't take the natural log of a negative number. So a little Control A, Control C, and dump that into Desmos. I'm going to move over here. That is number 7. And look. So I can have negative answers. I just can't take natural logs of negative numbers. So negative 4.6137. Okay. So grab it, copy, and paste. So the answer approximately $. Okay. Questions? All right. Verse. Solve the log. Let's do 13. Okay. Try 13. Skipping around. I have a variable in a place that I can't solve it for in its current location. So my last one, my variable was in the exponent. This one, my variable is part of the log. So the last one, I changed it into logarithmic. This one, I'm going to change it into exponential. Okay. What's my base?
5.
That's what I start with. When you change from logarithms into exponentials, start with your base. So start with the number 5. Okay, remember the logarithm equals d. So 5 to the third power is equal to 2x plus 10. Okay? 5 times 5 times 5 is 15, right? No. It's 125. Okay? So 1, 2, 5. And now this is a middle school math problem. Okay? Once I've changed it and converted it, and then taken 5 to the third power, subtract 10, divide by 2. So 115 divided by 2.
Yeah, I know.
Okay, so subtract the 10. I got 115 divided by 2. Depending on the way it looks on a test, it might be a decimal. It might be an imperfection. It might say it's 57 and a half. You just have to look, okay? Should we check? It's a logarithm equation. Okay, so dump it in the Desmos. Log base 5 of 2 times 115 halves plus 10. Make sure it's equal to 3.
Yeah, that's right.
On your last quiz, you might have noticed, prior to the graphing calculator era, you could do log base 10 or log base e. And actually, I had one student, period 2, who solved this using log base e. So you can use any base you like, but what base is the least amount of work? 4. Okay? Because that's the one attached where the variable is. Since the variable is attached to base 4, that's what base you should use. Okay? You can use any base you like, and you can use the my brain fart.
It's all right.
No, you can just use any base you use. I'm trying to make it more complicated than this. So log underscore 4 of 4 to the 2 plus x. Why does this make it simpler? What's my next step? We've done this now a couple times.
Oh, yeah.
Next step. Where's that exponent going to go? In oh, hello. That's a little too much. Where does it go, Denise? In front. And what is log 4 base 4? 1. Okay, so I have x plus 2 or 2 plus x. I'll keep it the same, even though commutative property says I can write it any way I like. But log 4 base 4 is 1, so do I need that anymore? Do I need the parentheses anymore? Nope. So I got x equals. And the hardest part about this stuff, I'll do 2 plus x, is the answers are not what you're used to seeing. Because you are now sophisticated math students, and your answers are no longer looking like they were in elementary school anymore, because you're not in elementary school anymore. So my final answer here, move the 2. Can I subtract 2 from the 12 and make that log base 4 of 10, Santiago? No, okay? It's log base 4 of 12, pause, get the answer, and subtract 2. Because this is really saying 4 to what power is 12? Well, 4 to the first is 4, 4 to the second is 16, so it's about 1 point something. So it's actually going to be kind of close. Let's just take a look in Desmos. I'm going to just drop it down to the bottom. So I got log base 4 of 10 is 1.6, and log base 4 of 12. Okay, see they're close, but that's this one I already subtracted the 2. When I subtracted 2 here, now they're not anymore close. This answer is negative. So negative 2.075, and the 1's not going to make it round. So that's my answer there. So final answer is about negative, and it should be, because I'm taking 2. What's 4 squared? 16, which is bigger than 12. So don't I have to make the exponent a little bit smaller to make it equal to 12? Well, the only way to make it a little smaller is to add a negative number onto it. Okay? So I can check this. So number 20. So 4 to the power of 2 plus, oopsies, I'm going to need parentheses, plus negative 0.2. That's pretty close to 12. And the more decimal places I put, the closer I'll get to 12. 0, 7, 5, 1, 8, 7, 4. Too many fours. Sorry. 9, 6, 3. Ready? Is it actually exactly 12? No, because Desmos is rounding this off. And eventually Desmos will round off to the nearest whole number if you have so many decimal places. It's like, if there's like 0.000 and like 15 zeros and a 1, it's just going to make it 12. Okay. All right. Questions? Oh, we're doing good. Caleb, 22 or 23? 23. All right. 23. Go for it. So since we can only have one logarithm on this side, let's see. Did we have anything where we combined logarithms into a single expression? Yeah, and last time we used quotient rule, and this time it's plus, so we're going to use product rule. Okay? It's just like this problem here. We need to combine the logarithms to a single logarithm. So let's take a moment. Product rule. So log base 2. We're going to multiply these two things. Okay? This is a good choice, Caleb. Good thing we went over this one. Everybody say thank you, Caleb. There you go. That was almost heartfelt. All right. Multiplied by 7 minus x. What do I do at the right-hand side? Nothing, because all I did was combine my two logarithms. I didn't take the logarithm on the left-hand side. It was already there. Now that I have a single logarithm, what can I do? Change it to exponential. 2 to the power of 1. Don't make it more complicated, because if we put the variables up top, now we have complicated things. The whole idea here is we need to remove the variables from the logarithm. So 2 to the power of 1 equals, and then let's start multiplying. X times 7 is 7x. X times minus x is minus x squared. Minus 4 times 7 is minus 28. Minus times a positive, minus times a minus is a positive. And there we go. Okay? What do we have to set this equal to in order to solve it?
0.
0. So move the 2, because 2 to the first is just 2. And you do the rest. And then make sure you check, because you might have an answer that is extraneous. Torrid, did you have A or B? Did you have positive 5/3 or negative 5/3? Did you tell me it was extraneous? At this point, my recommendation is to simplify and set it equal to 0. So I move everything to this side. Ready? Control A, Control C, Control V, and I'm basically going to change everything. Okay? The only thing I'm leaving there is the 2. Okay? The negative x squared becomes positive x squared. Remember, look what happened. I put it on this side, and it disappears on the other side. Ooh. Okay? 7x plus 4x is positive 11 on the right side, but negative 11x on this side. Okay? Negative 11x. If I add 28 to 2, I get 30. Oh dear, oh my, what am I to do now?
The x number.
Vector. Are there two numbers that multiply to be positive 30 and add to be negative 11? Uh-huh. Okay, so I get x plus, x minus, sorry, 5 and 6.
If I was negative 6?
They're both negative.
Yeah.
Okay. So close equals 0, and then we check. So 5 minus 4 is 1. Right? 5 minus 4 is 1. 7 minus 5 is 2. What's log 2 base 2?
1.
So that works. Well, let's try 6. 6 minus 4 is 2. 7 minus 6 is 1. 2 to what power is 1? 0. So I got 2. Log 2 base 2. So 1 plus 0 is 1. So do I have any extraneous solutions? No. Both work. So I got x equals 5 and x equals 6. Okay. So both of them work. Questions? All right. So I am going to stop for now. You have a